Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome. We are right now learning the subject of machine design 1. So far we have seen many properties of materials. In last lecture we have seen different kind of stresses, how to identify them and what are the empirical formulae. Now once we know that stresses are induced, they may fail the product. Stresses are not desired things. Somehow stresses are the good identification if the product is going to fail or not. It's like tonsils. A tonsils gives us the identification, or it gives us the warning that something is going to be wrong with you. Similarly, the stresses, when they induce, they tell us that something is going to be wrong with your product, and that's why stresses are important. But if the stresses are overcome by the values, means what are the preferred values of stresses there, if the values go beyond that, the product is going to fail. Now what we have seen till today is different types of stresses acting on bodies. Somehow that is not always correct. Guys, we know that, for example, normal stress is induced when the normal force acts. Shear force is induced when shear force acts, right? But somehow in day-to-day life or actual examples, real life examples, they won't go one by one. They always will come together. For example, if there is an element, or if there is a machine or a machine component which is under the action of multidirectional forces, there will be not only the normal stresses but also the shear stresses induced in them. So in such case, our empirical formula will not give us the exact answer. We will have to find out some other way out. So this other way out was proposed by different scientists by means of theories of failure. Three such important theories we are going to look at today, which give us the idea of the failure of the product. As you can see, the very first theory is going to be your maximum normal stress theory. Now we know that the stresses in real life are going to be combination of different stresses, and for that let us summarize that the stresses will be the relationship of, or the theories of failure are going to propose the relationship between strength of material and the stresses induced in them and the material properties. So theory of failures in short are going to give us the idea about the strength of material with respect to the stress induced and with respect to the properties of material. Let's start with the first one, maximum shear stress theory. There is a proper statement of the theory. Of course, you can refer to the books for the statement. The theory states that a product fails under shear stress. Sorry, let me correct myself. A product fails under normal stress when the stress induced in that product overcomes or it surpasses the actual yielding stress or actual ultimate stress of the specimen which was used in tensile strength. Guys, what is the meaning? They say that if there is a product and that is undergoing some loading, in such case we are going to consider only normal stresses as per the first theory. So the theory originator, who was Rankine, says that if the normal stress induced surpasses the stress that is induced, the yield strain that is induced in a sample material which was used for tension test, then the product will fail in that test, and the failure will be called failure of normal stress, or failure will be caused by normal stress. So that was the Rankine theory. So what happens in this theory? Let's look at the calculation part or the empirical relation. He says that the stress which is working when it equals to the yield stress, we'll call it yield stress, then the product fails. So in short, what does it tell us? It tells us that you should design a product in such a way that it will never surpass sigma y. So if the stress values are less than sigma y, the product is going to be safe always according to the normal stress theory. Normal stress theory. Somehow, before couple of lectures, we have seen factor of safety, which is very important. So if I consider the factor of safety, no matter whether it is 1, 1.5 or 2, the actual value of stress that I can afford comes down. So that will be given by sigma y divided by FOS. So in short, your working stress should not go beyond this particular value. This should be your ultimate value, maximum value. But we know that there are two theories. This particular value is valid only for ductile materials. So what about brittle materials? The only thing is sigma working becomes equal sigma ultimate divided by FOS. Rest of the logic, rest of the theory is same. If it becomes equal, it fails. So if I consider FOS, it is going to be, now earlier case it was failing, since I have considered FOS, it will become safe. Same thing about it, it becomes safe. The only difference is it is for brittle material. So that was our first theory. Let's move on to the second theory. It says maximum shear stress theory. Now, there was another statement given by Coulomb. Coulomb was a scientist at his time. He proposed that the failure does not occur because of the normal stresses. They occur because of the shear stresses. So the theory states that if the shear stress occurred in a part subjected to different loadings, maybe biaxial, triaxial, I hope you understand what is biaxial, triaxial, in 2 axis and 3 axis, if the loading is there, in that case, if the shear stress induced surpasses or if it is greater than the shear stress which is induced in a sample test specimen of its shear stress, then the product fails. In simple language, if you have a product, if it is undergoing n number of forces, and if you consider only shear stress in that, if the value of that shear stress is greater than the value of shear stress that is generated in a sample specimen which was used for its tensile test or shear test, in that case the product fails. So in simple language, maximum shear stress theory tells us that your tau working, what we know is shear stress is shown by tau. So tau working is equal to the maximum shear stress that induces. So I'll call it tau max divided by factor of safety. If this is the case, yes, your product is safe. But if this value becomes greater than this, your product is going to fail. So only up to this condition your product is going to be safe. And this we are considering only shear stress. Well, according to that, he actually decided some criterias and then he came out with a result which we are going to write down now. Guys, you are aware of Moore's circle. Moore's circle gives us the relationship between maximum shear stress and principal stresses. Let us say the principal stress in one particular element is exactly equal to its yield point stress. So, principal stress is exactly equal to its yield point stress. It was also found through Moore's circle that tau max is equal to half of its principal stress, which is exactly equal to half of its yield stress. And hence, for all mild steel problems, I hope you understand mild steel. For all mild steel problems, we take tau max, which is shear stress induced, working one of course, is equal to sigma y divided by 2. But this is the superficial value. If I consider factor of safety, I must consider FOS. So in that case, the tau max value is equal to 0.5 times sigma y divided by FOS, which is going to be my ultimate expression for tau max for the maximum shear stress theory. Let us move on and look at the last theory, that is distortion energy theory. Distortion is related with the destruction. Energy is something which is in the form of energy, right? And theory. So it is something which is related to the energy which is required for distortion. Now guys, when we know that the bodies, when subjected to different kind of loadings, there is work done, and that work done is stored in the form of energy. If the destruction happens, that is because of the energy which was stored or the energy which was released, right? So in such case, when distortion energy theory came up, they said that if the energy of distortion, that is the energy required for the distortion is equal to or greater than the energy of distortion required for the unit specimen undergoing tensile test, then the product fails. Again, in simple language, if you are considering a part which is undergoing biaxial or triaxial forces, and there is some energy volume that you are going to consider, if that energy volume is greater than the unit sample energy volume of a specimen which is undergoing tensile test, in that case it is likely that your product is going to fail. So this particular theory is called energy distortion theory or distortion energy theory. So what is the only important thing is, they found that there is a direct relation between them. The stress induced in this theory is given by, we will call it sigma working only, because this is the actual value of stress which is going to develop. Of course, it is given by your ultimate or yield strength or sigma ultimate. This is for ductile materials and this is for brittle materials, divided by FOS divided by FOS. So in short, this particular value, they found out this particular formula, which is equal to square root of sigma 1 minus sigma 2 square plus sigma 2 minus sigma 3 square plus sigma 3 minus sigma 1 square. Now using this particular formula, they found out the value for sigma working, whereas sigma 1, sigma 2 and sigma 3 are nothing but stresses induced in triaxial manner. So sigma 1 is the stress in first direction, sigma 2 in second direction, sigma 3 in third direction. Of course, we know that if it is a bidirection, sigma 3 term will be cancelled off. So remaining will be only in terms of sigma 1 and sigma 2. So the sigma value or the stress value which is obtained using this empirical formula is the stress induced at the point when the energy distortion theory is applicable. So guys, that is from my side about the theories of failure. See, every theory of failure has got some significance over different conditions. Some theories are very well proven for some sort of objects, and some theories are very weak in case of some sort of objects. During numerical solving, we will be looking at these theories, we will apply those theories, and then we will move ahead with the application of those theories. Thank you so much for watching the video. If you like this video, subscribe to Ekeeda. Thank you. See you.